Okay, welcome back. We are in lesson 11, implicit differentiation, and we are going to solve 10 problems for implicit differentiation. We start. Let me tell you that maybe you don't need to do all the 10 problems. It's fine if you do the first 5 problems. The first 5 problems will give you the skill that you need in using implicit differentiation. So if you are encouraged to do all the 10 problems, and go ahead. Let's go to start. Number 1, say, find the derivative of y respect to the x in the equation x squared plus y squared equal 9. This equation is the equation of a circle. The circle have radius 3, and we need to find the slope. The slope, this is the circle of radius 3. The radius is 3, and we need to find the slope at any point. Here, the slope is negative. Here, the slope is 0. Here, the slope doesn't exist. Here, the slope is negative, but here, the slope is positive. And what is the slope? The slope depends on the point x, y. The slope depends on the point x, y. So let's go to do the problem. We have the equation x squared plus y squared equal 9. What we do to find the derivative of y respect to the x using implicit differentiation is to do the derivative respect to the x of the whole equation. What is the derivative respect to the x of x squared? Is 2x, is the power rule. What is the derivative respect to the x of the function y squared? Well, the power rule mixed with the chain rule will say that the derivative is 2y multiplied by the derivative of y respect to the x. So here I have plus the derivative of y squared, which is 2y multiplied by the derivative of y respect to the x. And here I have what I'm looking for, the derivative of y respect to the x. What is the derivative of 9? 0. So I can solve for the derivative of y respect to the x. So if I solve for the derivative of y respect to the x, I will have 2x, or x equal minus y multiplied by the derivative of y respect to the x. So the derivative of y respect to the x, it will be equal minus x divided by y. What it means this? It means that through the circle of radius 3, if you go to the point, for example, x, x equal 1/2, now I need to find the y that is on the circle. And the y that is on the circle, because x squared plus y squared equal 9, means that the y that is on the circle is 2y's plus minus 9 minus 1/2 squared minus x squared, or plus minus square root of 9 minus 1/4. Or y, if x equal 1/2, the y will be plus minus square root of 36 divided by 4, which is 9, minus 1/4. Or the y will be plus minus square root of 35 divided by 4. So it's like something approximately like 4. It's not 4. Square root of 35 is 6. and square root of 4 is 2, 6 divided by 2 is more or less like 3, sorry. Like 3, more or less. It's not 3. So what happened at this point? Well, the slope at this point, at the point x equal 1/2, y equal almost 3, that is a point that is on the circle of radius 3. So the y is square root of 35 divided by 2, or minus square root of 35 divided by 2, whatever you want to plug in. The slope is here. Here is the slope. The slope is minus x divided by y. So if y is this point, the slope at this point is this slope, which is negative. So it will be minus the x. The x is 1/2. And the y is almost 3. So it would be a square root of 35 divided by 2. So this is about 1/2 divided by almost 3. So it's approximately 1/6. So if you go to the point here, to this point, to the point minus square root of 35 divided by 2, the slope is positive, and when you plug in numbers, the slope will be equal, when x equal 1/2, y equal minus square root of 35 divided by 2, and the slope will be minus x minus 1/2 divided by minus square root of 35 divided by 2, and this will give minus 1/6. It's true. The slope here, the slope here is positive, so this is positive. Minus is positive. So the slope here is positive with a value of 1/6, while the slope here at this point is negative with the value of minus 1/6. Am I correct? Is minus here. This minus is here. I'm sorry, minus 1/6. So let's go to the next problem. The next problem says, find y prime on this equation. What is the method? We do the derivative with respect to the x of the whole equation. The equation is x cubed minus xy plus y squared equals 7. What is the derivative of respect to the x of x cubed? 3x squared. What is the derivative with respect to the x of x multiplied by y? We need to do the product rule. Plus, what is the derivative of y squared? Is 2y multiplied by the derivative of y respect to the x. What is the derivative of 7? 0. So it will be 3x squared minus the derivative of the product. So I'm going to develop this part, this product, x multiplied by y. The derivative of the first is the x. The derivative of x respect to the x is 1. Multiplied by the second, y, plus the first by the derivative of the second, the derivative of y respect to the x, the second, plus 2y, the derivative of y respect to the x equals 0. So I have done the derivative of x of the whole equation. So now let me take common factor to the derivative of y respect to the x. So it will be 3x squared minus y plus the derivative of y respect to the x that multiply a x plus 2y equals 0. So I'll go now 3x squared minus y equal minus the derivative of y respect to the x multiplied by x plus 2y. And what is the derivative of y respect to the x? The derivative of y respect to the x is 3x squared minus y divided by x plus 2y with minus sign. And we have done the derivative of y respect to the x at any point x, y. At the point 1, 0, for example, the slope will be minus 3 divided by 1, minus 3. This is the slope. And you will not guess what is the slope, and you will not find who is y of x. You cannot solve for y in this equation and find the derivative of y respect to the x. So implicit differentiation is powerful. Okay, problem 3 say, find y prime by implicit differentiation y equals sine of x multiplied by y. You cannot solve for y, so it will better use implicit differentiation. So we have the equation y equals sine of x multiplied by y, and we make the derivative respect to the x in both sides. If we make the derivative, in the left side will be the derivative of y respect to the x. In the right side will be the derivative respect to the x of sine of x multiplied by y. So now let's go to do the derivative respect to the x of sine of x multiplied by y. This is cosine of x multiplied by y by the derivative respect to the x of x multiplied by y. So the derivative of y respect to the x is cosine of x multiplied by y, open parenthesis. Now I have a product, x multiplied by y. The derivative of the first multiplied by the second, plus the first multiplied by the derivative of y respect to the x. And now I almost done. Let's go to take common factor the derivative of y respect to the x. So the derivative of y respect to the x that multiply 1 minus x cosine of x multiplied by y. This is equal cosine of x multiplied by y multiplied by y. So I'm done. The derivative of y respect to the x is y cosine of x multiplied by y, 1 minus x cosine of x multiplied by y. You plug in any numbers x comma y and you will find the slope at this point. Okay, problem number 4, find y prime by implicit differentiation. Okay, we do the same thing. We do the derivative respect to the x. You see, it's impossible to solve for y. It's impossible to solve for y of x and make the derivative. So tangent of x plus y equal the derivative respect to the x of x. The derivative respect to the x of x is 1. And the derivative of tangent of x plus y is 1 divided by cosine square of x plus y. This is the derivative of tangent of x plus y multiplied by the derivative respect to the x of x plus y. And what it will be this? This will be 1 divided by cosine square of x plus y multiplied by the derivative respect to the x of x, 1, plus the derivative of y respect to the x equal 1. So now I will put the derivative of y respect to the x in the other side of the equation. 1 divided by cosine of x squared x plus y minus 1 equal 1 divided by cosine square of x plus y multiplied by the derivative of y respect to the x. And now I have to solve for the derivative of y respect to the x, which is equal to 1 cosine square of x plus y minus 1 is 1 minus cosine square of x plus y divided by cosine square of x plus y. So the derivative of y respect to the x will be equal to this, that is this, multiplied by cosine square of x plus y. So at the end, the derivative of y respect to the x will be equal to 1 minus cosine square of x plus y, because this will cancel with this. But I did a mistake. Here there is a minus sign. So here there is a minus sign. So here there is a minus sign. So the final result should be the derivative of y respect to the x equal cosine square of x plus y minus 1. And this is the final result. Okay, now problem 5 says find the slope of the tangent line. So we need to find first the derivative. Well, we need to find the derivative of y respect to the x. And we need to set up for the point 2, 2. So the derivative respect to the x of 4 minus x multiplied by y squared equal the derivative respect to the x of x cubed. What is the derivative respect to the x of x cubed? Is 3x squared. What is the derivative of this product? Is the derivative of the first of this product, the product of 4 minus x multiplied by y squared. The derivative of the first is the derivative of 4 is 0, the derivative of minus x is minus 1, multiplied by the second, plus the first, 4 minus x, multiplied by the derivative of the second. The derivative of y squared is 2y multiplied by the derivative of y respect to the x. And this allows me to solve for the derivative of y respect to the x. So let's go to do it. I put 3x squared in this side, and I will write y squared. This term, I will put it in this side. And this, I divide by 2 times 4 minus x multiplied by y, and this will be the derivative of y respect to the x. Now, I plug in the number 2, 2. So the derivative of y respect to the x at the point 2, 2, x, y, will be 2 squared will be 4, 12, 12, plus 2 squared will be 4, divided by 2 times 4 minus 2 will be 2, 2, and multiplied by y, that is 2. So it will be 16 divided by 8. Or, if I divide by 2, is 2. Okay. Let's go to the next problem. The next problem says find the equation of the tangent line. To do the equation of the tangent line, I need the slope at the point 4, 4. So let's go to do it. So we do implicit differentiation. The derivative respect to the x of x plus 2 squared plus y minus 3 squared equals 37. What is the derivative of x plus 2 squared? Is 2 times x plus 2. What is the derivative of y minus 3 squared? Is 2 times y minus 3 multiplied by the derivative of y respect to the x. What is the derivative of 37? 0. So this equation allows me to solve for the derivative of y respect to the x. So because it's equal 0, I can take these 2. So it will be x plus 2 will be equal y minus 3 multiplied by the derivative of y respect to the x. So the derivative of y respect to the x will be x plus 2 divided by y minus 3. Because they want the slope at the point 4, 4, so it would be 6 divided by 1. So the slope is 1. And what is the equation of the tangent line? So the point x0, y0 is the point 4, 4. And the equation of the tangent line is y equal y0 plus m multiplied by x minus x0. So in this case, the equation of the tangent line to this curve, to this graph, it would be y0 would be 4 plus m, 6 divided by 1 is 6, okay? Plus 6 multiplied by x minus 4. So the equation will be equal 4 minus 24 plus 4 is minus 20. So it's 6x minus 20, the final result. And again, I did a mistake here. Here I did a mistake with a minus sign. X plus 2, y, there is a minus sign here. So the derivative is minus 6. So let me correct the minus 6 here. So it's minus 6. And now let me erase here and redo the calculation. So it will be y of x equal, it would be minus plus 24. Plus 24 plus 4, it will be 28. So it will be minus 6x plus 28. And this is the final result. I'm sorry. This problem is interesting also. It's find the second derivative. To find the second derivative, we need to find first the first derivative. Y squared equal x cubed. What is the derivative of y squared? To y by the derivative of y respect to the x. What is the derivative of x cubed? 3x squared by the derivative of x divided by the derivative of x, which is 1. So that's why I never write it. Okay. So now I have this equation, and it say find the second derivative. So I have here the product of two functions. So it will be the derivative respect to the x of the whole equation. To y, the derivative of y respect to the x equal 3x squared. What is the derivative respect to the x of 3x squared? 6x. What is the derivative of this product? It will be the 2, let me put these 2 outside, 2 times, it will be the derivative of the first, the derivative of y respect to the x, by the second, multiply by the second. The second is the derivative of y respect to the x, so it will appear a square, plus the first multiplied by the derivative of the second. The derivative of the second is the second derivative of y respect to the x squared. So I have that the second derivative of y respect to the x squared multiplied by y is 6 divided by 2 is 3x. 6 divided by 2 minus the derivative of y respect to the x, the first derivative is squared. So the second derivative, there is second derivative of y respect to the x squared should be equal to 3x minus y prime squared divided by y. Now, if you want to express this equation in terms of y and x, not in terms of y prime, like here, you need to do the following thing. From here, from this equation, I can find from this equation, I can find the derivative of y respect to the x is 3x squared divided by 2y. So let me put it here. So it will be the second derivative of y respect to the x will be equal to 3x minus y prime. Y prime is 3x squared divided by 2y. 3x squared divided by 2y is squared divided by y. And now is in terms of x and y. So it would be 3x minus 9x4 divided by 4y squared divided by y. Or 3x divided by y minus 9x4 divided by 4y cubed. And this is the final result. Now problem 8 is an interesting problem also. It says air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. So the change in the volume per unit of time is a constant rate of change, and you put inside the spherical balloon 4.5 cubic feet per minute. Cubic feet per minute. Every minute goes inside the balloon. And they say find the change in the radius when the balloon is 2 feet. So the volume of a balloon is 4/3 pi r cubed. So when there is a change so we do implicit differentiation. We do the change in the volume per unit of time in both sides. So it's the change respect to the time of 4/3 pi r cubed. So it will be the change in the volume respect to the time will be 4/3 pi. Now the change respect to time of r cubed, it will be 3r squared multiplied by the derivative of r respect to the t. So we know that this is 4, we know that the change in the volume per unit of time is 4.5. So what will be the change in the radius per unit of time? So a change in the volume induces a change in the radius. So if you change the volume, you change the radius. So the problem is here is if the change in the volume is 4.5, what is the change in the radius? If the change in the volume is 4.5 cubic feet per minute, what is the change in the radius per minute? 4/3, and the answer is here. The 3 will cancel, so the change in the radius respect to the time will be 4.5 divide by 4 pi multiplied by r squared. If we plug in numbers when r is equal 2 meters, the change in the radius will be 4.5. The change in the radius per unit of time divided by 4, 3,14 multiplied by 2 squared, which is 4. And this will be approximately 2 squared here, 2 squared here. So it will be approximately 4 by 4 is 16. 4.5 divided by 16 multiplied by 3. 16 multiplied by 3. Let's go to leave it like pi. 16 pi. 16 pi. And 4.5 divided by 16 pi is the same that 9, that is the double, 32 pi. And now I can take a calculator and see how is the change in the radius in feet per second. Per minute, sorry, not per second, per minute, so how much it would be? I need to take a calculator, but 932 is 100, so 32 by pi is like 100, and 9 divided by 100 is 0.09, more or less 0.09 should be. Okay, let's go to the next. Okay, let's go to do problem 9. It's a 25-foot ladder. It's leaning against the wall of the house. So this is the house. This is the wall of the house. Okay. This is the ladder. The length of the ladder is 25 foot. And the base is pulled with a velocity v sub x, 2 feet per second. So this point is moving 2 feet per second. So this is the velocity of this point. And when he moves, this point will move with velocity vy. The velocity vy is the derivative of y respect to the t. Is the change in the y position of this point respect to the t. And what it says, when this is 7 feet, what is the velocity v sub y? Okay, so we need to write an equation, and the equation is nothing else than Pythagoras theorem. This is the x, and this is the y. So 25 squared is x squared plus y squared. Now, if I make implicit differentiation here, the derivative of 25 squared is 0. Now, I'm making implicit differentiation by taking this equation and find the derivative not respect to the x, to the time t. So I'm going to take this equation and I make implicit differentiation to this equation. So the derivative of 25 squared is 0 respect to the time because it's a constant. The derivative of x squared is 2x multiplied by the derivative of x respect to the t. And the derivative of y squared is 2y multiplied by the derivative of y respect to the t. So what happened? The derivative of x respect to the t is the velocity v sub x, is the 2 feet. The x is the 7 feet. The y, well, the y I know because if this is 25 and this is 7, Pythagoras theorem will tell me what is vy. And what I want to find is v sub y, the derivative of y respect to the t. So let's go to find the derivative of y respect to the t equal minus 2 times x, derivative of x respect to the t divided by 2y. Now let's go to plug in numbers. Minus 2. X is 7. The derivative of y respect to the x is 2. 2 times y. But what is y? Y is because this is a triangle and the triangle have 25, 7. This y is 25 squared minus 7 squared is the y squared. 25, this will be 7 squared is 49, and 25 by 25, I don't know. But y is a square root of 25 minus square minus 49. And this, let me check in the calculator, is 24. So y is 24. So what is the slope? what is the derivative of y respect to the t? What is the v sub y? The velocity v sub y, the derivative of y. Minus 2, 7, the 2, and 2 times y, 2 times 24. 2 times 24. And now I can do the calculation and I can say what is the velocity going down, this velocity going down at this point. And what is this velocity? Let's go to find it. The 2 and the 2 will cancel, these 2 with these 2 will cancel, and 24 is 12 by 2, so it will be minus 7 divided by 12. And this is the velocity going down, because it's negative. So it's minus 7 divided by 12 feet per second. Let's go to the next problem. A conical tank with vertex down is 10 feet. So this is the conical tank, is a cone. This is the conical tank. And the tank have the radius here is 10 feet across the top. So this is 5. This is 5. And at the top and 12 feet deep. 12 feet deep means that this is from here to here, this is 12. So this is the floor and this is 12. Okay, and the radius is 5. A conical tank with vertex down is 10 feet across the top and 12 feet deep. If water is flowing into the tank at a rate of 10 cubic feet per minute, so there are volume coming. The amount of volume that is coming per unit of time, the change in the volume per unit of time is 10 cubic feet per minute. So every minute is coming 10 cubic feet to the conical tank. So it says find the rate of change of the depth of the water as the water is 8 feet. So this is the height h, and it says find the derivative of h respect to the t. Find the velocity at what the h is coming up. Interesting problem. So how we will do this? As you see, the volume, because it's entering a constant volume to the tank, to the conical tanks, at the beginning, the h will grow up very, very fast. But as the tank is being filled, the h, the height, will grow up smaller. So what we have to find is the derivative of h respect to the t, and it say find this derivative, find the velocity of the h when the tank when the h is 8 feet. So let's go to do it. First of all, we say the volume of a conical tank, the volume is 1/3 of pi, 1/3 pi of the area of the vase, pi r squared. So this is the r. This is the r. And this is the h. This is the h also. This one is the h also. So the volume is of a small cone of radius r, little r, is 1/3 pi r squared multiplied by h. Okay, now let's go to relate it, the r with the h, because we will need it. If you see here, this angle here, theta, this angle, let's go to do it like this. This angle theta, tangent of theta is r divided by h. You see the triangle. Let's go to write the triangle here. This is r and this is h. So the tangent of this angle is r divided by h, but because it's the same angle, it's also 5 divided by 12. This allows me to find r as a function of h. So what is the radius when there is some h? And the radius is 5 divided by 12 multiplied by h. And what happened now? Now I'm going to plug in this here in the equation for the volume, and I'm going to use implicit differentiation to find the derivative of h respect to the t. Let's go to do it. So the volume will be 1/3 pi r squared. R squared will be 25 divided by 144 h squared. R squared multiplied by h. So the volume will be 25 pi divided by 144 multiplied by 3 h cubed. This is the volume. So we know that the change in the volume per unit of time, this is 10 cubic feet per minute. 10 cubic feet per minute is constant. You are putting inside the conical tank, 10 cubic feet per minute. Okay, and what I want to find is the derivative of h respect to the t. How fast the h is growing up respect to the time. So we will do implicit differentiation here, and we will find the derivative. We make the derivative respect to the t in both sides of the equation. So the constants will be here 144 multiplied by 3 by the derivative respect to the t of h cubed. Okay, so the derivative of the volume is 10 respect to the time t. You are putting in the cone tank 10 cubic feet per minute. Well, this is a constant, 25 divided by pi divided by 144 by 3. I don't know how much it is, whatever it is. By multiply by the derivative of h cubed respect to the t. This is 3 times h squared multiplied by the derivative of h respect to the t. And now I'm done. H, when h is what? When h is 8 feet, at the instant that h is 8 feet, the derivative of h respect to the t is 10 times multiplied by this 3 will cancel with this 3, okay? So it will be 10 times 144 multiplied by 100 divided by 25 pi divided by h squared, 8 squared. And this is the velocity at what the h is coming up when the height is 8 feet. So how much it will be? Let's go to calculate. Approximately, you can do it. It will be 1,440, 25 pi 64 multiplied by 25 times pi 3,14, and how it will be this you make the calculation, but I suppose that should be 64 by 25 is like 1,440, so it will be maybe 1 divided by pi, or 1/3. 1/3 what? 1/3 meters per second, going up. The height is coming up. And this is the problem. It's an interesting problem. So you are filling with water. You are filling with 10 cubic feet of water per minute, and the height is growing up. It's going up. At the beginning, it's growing up very, very fast. But when the height is big, the amount of height is smaller, and the velocity when the height is 7, like here, the velocity going up of the surface of the liquid is like 1/3 meters per second, or feet per second, sorry. Should be feet per second because I'm using this unit. Well, this is the problem, and I'll see you soon.